Well, for a summary, we now have computed, we have reached the stuff for the next computation of the attention um, between those 50 different locations or units in the data with themselves, and we will compute the attention for 8 different aspects, which we call heads. Basically, we compute 8 different kind of tensions between these 50 and 50 units in the data. So it is ready. But in the next step, we cannot apply the same kind of matrix multiplication. Just use as what we have done. Look, if we do, we will be computing, let just take for example, remind the following operation is wrong. We cannot do this, but I'm demonstrating why it is wrong. So we will use the query to do the matrix multiplication with the case u q. We do the matrix multiplication for the trailing 2 dimensions. We treat we have b times m units, and if this unit we are considering a matrix. This, let's call them entries, because we have already said we have m units in one instance of the data. So for each of the entry, we consider that as a matrix entry, and the entry is k by p. So we take this matrix multiplication operator, and we let it to operate on the case, and we take the transpose of the last 2 dimensions, -2 and -1. Okay, let's just call that temp and see what we'll have. I think I've changed the cell into so seems there's no error, but let's check what we have in the term. George, look, that is 4 by 50 by 8 and 8. This is not what we want, because it would be like you are taking let's forget about the 4 thing. As before, we consider these 50 different units of the data, so we have 50 of them, and we want to compute the relationship between themselves, which will give us a 50 by 50 relationship matrix. Okay, so this is the ideal case, and that was done by doing by operating by do the pairwise inner product of the query vectors and the k vectors. So if this is a query vector and we have the similar sized k vector, we just need to take the transpose of the k vector, then we'll arrive at something. Let's remove this of this size, and by taking this kind of operation, we will get the desired 50 by 50 attention matrix. However, now because we have reorganized the data, so in each of the data, the trailing, which means the last 2 dimensions, will be the number of heads, head number, times the sub vector of the query. So let's call the 64 vector as a sub vector of the query, q sub. In this case, that will be treated as one instance that is of interest, because for the operator matrix multiplication, the only 2 dimensions that participate the computation will be the last two. So on the other hand, when we do the Simpson transposition of the key, we will have another head number times, that would be the 64 sub key vector times the head number. So we will end up with head number times head number. And that will be a matrix of attention. This attention will be the 8 parts of 1 unit, and we compute the similarity or how they are connected with each other. Basically, we are doing things like that. We take this long vector into 8 parts, and we stack them together in this way, and then we do the attention in this dimension, but that is not what we want. So there is one more trick we need to do, and that is illustrated here. This part, please give it a read. We will first transpose the middle 2 dimensions of those reorganized data. So we will change the dimension of 8 and 50. So basically, we reorganize the organization of the data and let the 8 different parts to take the dimension ahead, and let the 50 get into the last 2 dimensions. Therefore, we will compute the attention between these 50 different units within one data instance, and do the attention computation for 8 times. So this is our code, and if we execute attention using these two, let's do uk times uk dot transpose for the last 2. We will have let's put temp ship. Oh, sorry, I haven't executed this, so let me do this first. Yeah, this is what we want. So we have finished the basic computation of the multi-head attention. In the next step, we will consider how to use this computational step to form the data transformation mechanism. There are 3 kinds of them, and please watch our next video.